let's just stop talking about macrometers and that entire software stuff. It's not that I just don't want to hear about it anymore. But again, you have a macro, you have a user, you have a bunch of software you work with, and you want to use the macro user to perform more kinds of all the documents. Say more kind
I know. You guys can watch that on your own time. I'll send a link. That's James. James is very funny. And that talk is full of a lot of good points. So today what we're going to do is we're going to talk about a paper that James wrote. James Mickens, famous computer scientist. Definitely the Pareto optimal computer systems researcher when you talk about smart and funny. Like, there may be smarter researchers and there may be funnier people, but there is no systems researcher who is both smarter and funnier than James, right? That's a null set. I think you guys know this. People here maybe are done. How many people are done? Yeah, okay. Everyone else is just brave. let's kill some time in class. All right. So I like that. I'm taking a break, you know. Haven't slept for a while. You can do some sleeping now. That's cool. So 17% is where we were this morning. You guys have a long way to go to get to 70, 80, 95. It usually just goes upwards, hopefully. So yeah, please do the course evaluation. I'd appreciate that. Unless you're waiting to do it because you hate me right now and you think you might like me better in a few weeks, in which case it's fine to wait. Just don't wait until after the exam. All right, so we've talked about virtualization this week, and I thought this paper would be a fun thing to look at to sort of bring us full circle, because it's sort of interesting. I mean, we've been talking about operating systems and operating system concepts, and yet in the decades since operating systems were designed and implemented and distributed, the world has changed quite a bit. So I would say, you know, today, you know, millions of people create apps, right, that run in a sandboxed environment and manipulate a rich windowing interface in order to communicate with users. But those aren't native apps. What are they? These apps don't run on top of the operating system. Where do they run? You guys probably use these apps on a regular basis. How do you launch them? Where do they run? They run in the browser. How many native apps do you guys actually use on a day-to-day basis? How many people would say like under 5? Include the browser. For me, it's like browser, iTunes, which is a total piece of crap. I hate that app. I wish it ran in the browser. It could not run worse, right? It is the weirdest, most broken piece of software. Trying to think of what else. My terminal, I guess that counts. I'm at 3. Sometimes a PDF viewer, but that always makes me very sad when I have to do that. I would much rather have stuff like Google Docs. It's amazing that Google Docs' annotation features are better than PDF viewers. I find that to be shocking, but it is also true. So yeah, so I'm at like maybe 4, maybe 2 different PDF viewers because one of them's always broken in some weird way that the other one isn't. Anyone like 10? Maybe an IDE? So maybe we're at 6. Anything else?
Slack.
What? Slack? Use an app for Slack?
Yeah.
Why? Doesn't it run in the browser? I just go to some website. Oh, okay. That's just for notifications. Okay, that doesn't really count, right? I mean, normally you go to the web page, you use Slack. It might have an app that like pops up notifications or something. But Skype, maybe. What else? I mean, this number is dropping, right? What's that? LimeWire. Okay. Yeah, great. alert the FCC. What's that? Well, I don't know what that is. Oh, okay, gotcha. It's even dodgier. It's dodgier software than the dodgy version. Yeah, so like, this is interesting, right? And I don't, this is one of those technology transformations that I don't think anybody would have predicted 20, 30 years ago. That, native apps are, now native apps are alive and well in one place, which is kind of interesting. Where is that? Gaming. Okay, yeah, that's true, games, right? So games still, typically native apps, but there's one platform where native apps are still ruling, yeah, the phone. I don't know why that is. It's very interesting. I'm very curious to see what will happen. My prediction is that those apps are going to go away. So I love to point out the fact that my wife uses Facebook and Gmail on her phone, but she does not have those apps installed. She goes to the web page in Chrome, and that's how she accesses Facebook on her phone. The thing that's amazing is that works. And apparently it works well enough that it doesn't drive her crazy. Same thing with Gmail. Like the Gmail mobile interface is terrible. It makes me cringe. It's really ugly. But she does things with it. She sends messages, whatever. So yeah, I mean, at some point, it'd be interesting to see what happens on mobile. But I suspect that things are going to go to the web, right? Meaning that the code that you guys and most of the code that you guys download and run today is in this language called JavaScript. Right? How many days it took them to develop the first version of JavaScript? So I shouldn't have said days. I gave you guys a clue. Do you know how long it took them to develop the first version of JavaScript? 10. Sorry. Oh, come on. You can't develop a whole language in a day. That's ridiculous, right? 10 days, or 10 or 11 or something like that, right? So like Java, Sun spent years developing Java, okay? Java development started years before JavaScript development, and yet JavaScript was released before Java, right? I find that to be shocking. And that is the modern computing experience. So again, talk about unintended consequences, right? When Netscape decided to put JavaScript into the browser, I don't know if anyone at that point realized that that was going to change the entire face of computing, but it did. And so that's where we are today. If you want to write web apps, you have to use this nasty language called JavaScript that somebody wrote in 11 days. Yeah. Oracle? Java support? No. No. Yeah, no, Oracle doesn't support JavaScript, right? JavaScript and Java have nothing to do with each other, first of all. Just understand that. They're totally, completely separate, distinct, unrelated languages. They just happen to have similar names. It's very confusing. I know it confused me for a long time. No, JavaScript's not going anywhere. I mean, I think at some day we will have a replacement for JavaScript, but it will take a long time to emerge, right? But just the fact that we got to this place is, on some level, if you are sort of an ironic person, hilarious, right? Like, think about those people at Sun. It's like we spent years developing Java. It was going to run everywhere. Write once, run everywhere. That was our mantra. And this guy, in 11 days, beat us to the punch. And now JavaScript is what you write once and run everywhere, right? It is incredibly funny. Someone's going to write a book about this one day. Maybe it'll be me. I just think it's a fascinating story, okay? So what this means, the combination of the web and the fact that HTML, CSS is actually a pretty nice representation for lots of different types of apps. You can see it in lots of different types of places and different contexts. It means to some degree the web browser has become, in many ways, akin to a modern operating system. So the web browser is almost its own virtual machine. That when you go to a web page, you download a piece of code and run it inside this virtual environment. It is in no way similar to the virtual machines that we've been talking about in this class. It does not attempt to present any sort of hardware interface. But this is sort of how things work today, right? I mean, you call it an interpreter, call it whatever, but the structure of the browser means that it's taken on a lot of the responsibilities traditionally associated with the operating system. So multiplexing resources, right? Why does the browser have to do this? Why does the browser have to multiplex resources? When the browser is multiplexing resources, what is it multiplexing them between? Yeah, tabs or windows, right? I mean, in the OS, you talk about apps that are competing for resources. In the browser, you have different tabs running different websites that are also competing for resources, right? So this is sort of the equivalent there. Protecting applications from each other now becomes protecting unrelated sites' content from each other. This is super important. Why? Yeah. So that's nice. You have not allayed my fears. Yeah.
I could be typing in my social security number.
Yeah, when you go to like sketchywebsite.net and then you open up your bank in the other tab, you hope that sketchywebsite.net isn't getting leaked information from that other tab where you are entering your bank password. Okay? This is actually surprisingly hard to get right. And also when I start downloading various JavaScript resources and other things, there's rules about the types of content that they can have access to. And this is pretty important. People also do incredibly dumb stuff in their web browser. Did anyone fall for the whole Osama bin Laden death video thing that went around on Facebook a few years ago? Anyone remember that? Anyone see that? It was like, click on this link, or cut and paste this huge link that's like 30 lines long into your browser to see the hidden Osama bin Laden death video. Do you know what that was? That's a bunch of JavaScript that ran in your Facebook context and like spammed that message to all of your friends, basically, right? And yet like millions of people cut and pasted that into their web browser. Hey, let's try this, right? Let's see what happens when I don't know. I've never seen a URL that long before. Normally they're like 10 characters and this one is 10,000, but who knows? Maybe it'll take me to that Osama bin Laden death video that I really want to watch, right? I had a friend who used to work at Facebook and this sort of thing drove them nuts, right? Same thing here, right? So the browser provides an API. And that API in a lot of ways provides, again, sort of abstract resources, right? Whether it's events, the DOM, which is this abstract data structure that represents the content on the page that JavaScript manipulates in order to create the interactive web experience, right? So this is interesting, right? I mean, to some degree, the browser seems to have all these features that are very similar to the operating system, and now a lot, rather than having like 10 different icons on your desktop that you click to open native apps that do various things, you have 10 different browser bookmarks that you click to send mail and listen to music and collaborate with others on documents and whatever, right? Write code. I mean, that's clearly the next thing that's coming. There's already some tools out there like that. I mean, anything that you are not doing in the browser right now is going to go in that direction. In a lot of cases, there are already ways to do it in the browser, and they may not be beautiful yet, but they're coming, right? But what's the big difference here between, historically, between the operating system and the browser that might create some problems? So the operating systems were, when people designed operating systems, they had all of these things in mind. Right? There were these well-defined goals. We're going to protect applications from each other. We're going to, this was how operating systems were designed. This was part of the spec. They were already designed to do this. Whereas web browsers started life as applications, and over time, as we've been migrating more and more computing functions into them, they've sort of had to take on these new responsibilities in this really ad hoc way. So, for example, if you think about how web browsers work, the operating system does not allow an application to basically give it a huge chunk of code and say, I would like to run this in the kernel with kernel privilege, right? That would be a terrible idea. Whereas the browser, every time you go to a web page, has to take this huge mass of JavaScript and somehow run it, which is a Turing-complete language, and somehow run it safely inside that tab, right? So this is a much different challenge. And so browsers are probably not necessarily going to make very good operating systems, despite the fact that there's a huge amount of work in this area about how to make them better operating systems, including the work that we're going to look at today. All right, so I would encourage you to watch some of James's videos. They're very funny. They're also educational, so you can giggle along with him as he makes fun of JavaScript, and then also be learning something along the way. But I'm not going to try to sort of steal his thunder here. Instead, what I thought I would do is show you some of the video where he presented this paper, and I'll stop it at various points, and we can kind of explain what's going on. All right? So here is James. I'll turn the sound up.
Here's the motivation for this talk. Your web browser is a trainer, okay? It is one of those adversarial programming environments that Satan never created. Why is that? Well, the reason is that the APIs that it's supposed to implement are far too complex and maneuvered for it to do so in a consistent manner. And as a result, all of these web browsers are extremely brittle. This means that it's very difficult to write robust web applications atop that very brittle infrastructure. And so, in a nutshell, here's how we're going to solve this problem. We're going to take the traditional monolithic browser, which has all this code in it for doing layout, rendering, parsing, HTML, things like that. And we're going to strip that interface down. We're going to create an excellent interface. It's only responsible for doing very low-level things, rendering bitmaps, getting a little GUI and stuff like that. And then we're going to allow the page itself to specify its HTML parser, its DOM trees, layout, rendering, and so on and so forth. And what's nice about this architecture is that it allows pages to manage their own complexity. Now they don't have to rely on this sort of stuffy browser for their corrections. Now, I know what some of you in the audience are saying. Why do we need another browser? After all, using our current browser, we can fetch all kinds of exciting content, like Farmville, like weird internet ads, like online dating, and pictures like this. It doesn't even matter if it's real. Now,
all right, so let me back up a minute here. Unfortunately, I'm sorry it's so blurry. I don't, again, this was only a few years ago, but apparently the top conference in computer systems had not figured out how to videotape talks with a high degree of resolution. So I don't know. Maybe it's supposed to look retro, right? Like we're supposed to think, wow, this is a great talk from 1986. It's really amazing that they were able to videotape it at that time. So what's the overall argument here, right? So what is when we talk about the API, right, we're talking about the interface between, two pieces of software. What is the operating system API? You guys have been working with it this semester. I mean, what was the operating system API consist of? What's that? System calls, right? That is the operating system API that it provides to applications. That is how you get the operating system to do things on your behalf, like allocate more heap, like open files, whatever. And that API defines, to some degree, you can think about the security or the vulnerability of the operating system being a function of that interface. If that interface is well designed, and if that interface is small, too, which is also kind of important, then the attack surface is fairly limited. So you can think about it this way. The kernel has to support all of these different functions that applications can call. And on Linux, maybe there's like a couple hundred or something like that. Every one of those has to be completely correct for the operating system to be secure, and also for the operating system to be correct. Now, if I have a bug in some, rarely used system call, somebody will find it, and someone will produce a binary that exploits it and uses it to do something bad. Or it could crash the system or whatever. So the interface and all of the lines of code that are required to implement it are sort of measured to some degree the size of the problem that the operating system has to solve for it to be secure. All right? Now, to some degree, in order to improve security, operating systems have tried to keep this interface fairly limited, because that makes it easier for them to, there's just fewer lines of code to fix and make sure are correct. The web browser, on the other hand, what is the API that he's talking about that it provides? What is the web browser API, and who uses it? Give me some examples of things that must be part of the web browser API. Yeah. What kind of requests? Yeah, so the web browser gives me the ability to initiate network traffic. That is how every web page, reactive web page that you have been to works. So when you go to Gmail, it opens up some sort of network connection back to Gmail servers that is active for the life of your session. That's how That's how messages sort of just appear in your Gmail interface, is there is code running that has a network connection open to Gmail servers, and it got a message that said you have a piece of new mail. What else had to happen for that new message notification to show up? Yeah?
Rendering images?
Yeah, I mean, rendering images and sort of adjusting the DOM, right? So essentially, the DOM is this data structure that determines how the page is laid out. And when a new message comes in, I clearly need to add a new entry to the visual layout that you are looking at in order to alert you that that has happened. I have a new message. It has some styling associated with it so I can tell it's new. I update a number over in the corner that counts the number of new messages, et cetera, right? What else?
Be able to interpret the scripting language that the website was written.
Yeah, so to some degree, I mean, Rob's answer is the interface is used by JavaScript that comes on the page, right? So because again, I mean, to some degree, if there's no JavaScript, all that I'm doing is I'm just interpreting a static piece of HTML content that the web server sent me. And that's fine. That works very well if you have static content and it doesn't need to do anything fancy. But the API that he's talking about that the browser provides is provided to JavaScript that runs. So when your JavaScript starts to run on the page, there is this list of functions that it can call that will cause the browser to do various things. And that interface, first of all, was not really that well designed in the first place, certainly not designed to support these sort of rich web applications, and is enormous. It's got all sorts of functionality in it, and that makes it very difficult to get right, okay? So let him keep talking about the ways in which people get it wrong.
There's a dirty little secret about the web, okay? There's a secret is that the aggregate web protocol is actually huge as that. So what do I mean by the aggregate web protocol? Well, browsers have to support things like HTTP, for example, to fetch the content. They have to support things like HTML and CSS to actually structure and really interpretation of that content. They have to support JavaScript for client-side interactivity. That's both the core JavaScript that defines things like regular expressions, and also the DOM bindings, which allow JavaScript to interact with the rest of the browser. Now, don't forget, some people also use tablets. Don't know why. But it's actually what they're called. And while we're talking about plugins, let's also throw in Switzerland, throw in Glass, throw in QuickTime. Don't forget the Canvas and Video tag, which are these new suggestions for how to provide rich client-side graphics. And long story short, how much time do you have? As it turns out, writing a web browser.
So does this make sense? Like this, to some degree, what he's trying to describe is the aggregate functionality that web browsers are forced to support. So again, clearly I have to support the HTTP protocol because that's how I actually get the web page in the first place. If I don't support that, I'm in trouble, right? That's also frequently how JavaScript that runs in the browser accesses resources other places while the tab is open to do things like fetch new messages and upload things and blah, 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 okay? Obviously, HTML and CSS, that's how my pages are laid out. That describes how they're supposed to look. So when he talks about core JavaScript, he's talking about just the JavaScript, like the JavaScript language that you could run in like Node.js, right? JavaScript has built-in support for things like regular expressions and just being able to interpret JavaScript generally. And then the browser provides all these extra features to the JavaScript that runs on the page because, by the way, that JavaScript also usually wants to manipulate the DOM, right? That's how you get the page to look different. When you look at a web page and it changes appearance, it's because some piece of JavaScript manipulated the DOM and caused it to look different. And that can be done in a gazillion different ways, okay? Libraries like jQuery really started out as convenient ways to manipulate the document object model. Applets, yeah. Has anyone been to a web page that had an applet on it recently, like in the past couple weeks? Was it not, okay, let me ask a question differently. Have you been to a website not for a course you're taking that had a Java applet on it? All right, see, I got two of the hands that go down. Why?
We use really archaic software for work.
Oh, okay, yeah. So he was forced to, right? Like when I go to a page with a Java app, it's like run away right away, right? That's like one of the first things that will cause me to just close a tab. Like I don't care what it is, right? I'm not going to click 8 different checkboxes and then wait 10 minutes while the thing fires up and updates all the Java things in order to show me whatever crappy Java applet that's going to look super ugly you want to run in the middle of the page. Right? Just not doing that. Usually those pages haven't been updated since like the mid-90s anyway, so it's a good cue to go away, right? You've got all these other plugins too that on some level the browser has to be prepared to support. So when you embed a PDF into a page, or when the browser opens a PDF, think about it, like the browser has now become this, like the web browser has now become this like general purpose file browser. And have you guys, any of you guys ever used it this way? You can actually open local PDFs in your web browser, and a lot of times they look better than they do if you open them in Adobe Reader, right? And that's sad, but true, right? So to some degree, like you can use your browser to open local files, and sometimes it actually works out better than if you did it some other way. You have the secure web protocol. For some reason, I have to be able to open local files like I just said. I don't know what that's for. You have this idea of what are called web workers. So tabs are supposed to be able to provide bits of JavaScript that run periodically in the background to do various things. And so this is hard, right? This is a very, very big, complex interface that browsers are forced to support in order to sort of satisfy the needs of their users. And to some degree, I think I would argue, I think James would agree, that there wasn't a lot of thought that was put into this. It was kind of like, okay, like Microsoft came out with something called Silverlight, and then everyone has to support it somehow, right? Because the Olympics website used it once, right? And that was annoying. So like some of this is improving over time, right? But slowly. Right? I mean, I would argue that Canvas and video have made some of the GUI crap go away. I mean, the video tag's really nice. It replaces a lot of the old Flash and things like that. Anyway, so we're improving things over time, but this is really, really complicated. Oops, sorry.
Requires supporting all these different protocols. And don't forget, if you're a web developer, you're always asking, which version of these protocols does the browser use at the time you target, right? Because they're very popular deployed versions of all these protocols. So it's actually a big mess. So there are two implications to the fact that this aggregate web specification is huge. The first implication is that no single browser will ever get it right. I mean, in principle, we're told by our professors that standards give us order, right? But in practice, what happens in the web world is that there's so many standards and they're so complex that it's impossible for any single browser to provide robust implementation of these things that will clean in order for a web page. Now, the second consequence is that each browser will fail you in different ways, okay? And this is heartbreaking, right? But pick any two browsers, for example, you want to develop on Firefox, IE, it doesn't matter. If you want your web page to run on both those browsers, you're dealing with two sets of implementation work. You're dealing with two sets of implementation efficiency, okay? So this is extremely problematic.
All right, has anyone ever experienced this? Has anyone built websites? And like, you build it, hopefully you guys will all do this someday soon, right? Because again, like this is modern computing. So when you build a website, it's fun. You got this great looking page, put some work into it, looks awesome, it's running really well. And then you're like, I should check and see how it looks in Internet Explorer. And then it's just sadness, right? Because it doesn't look right. It's broken, things don't work. Zach, what's that?
I have an experience like that with Firefox compared to Chrome.
Yeah, so I had that experience the other day in here. I don't know if you guys noticed this, but like Firefox broke my slides, right? I don't know why, right? And I don't really care that much. But the website is only supported on Chrome. I'm going to put a logo on it, right? But yeah, Matt.
The ESPN like football like draft doesn't have it in Chrome. So
Yeah.
like I have to download Firefox, install it just to run the draft.
And actually more than that, even using like Firefox on Linux, tons of times when I'll go to sites, they'll just be like, oh, we don't support Linux. I'm like, well,
I hate you, yeah. Go somewhere else.
How about JavaScript slideshow that won't work in Safari?
Yeah. Yeah, yeah. So like this is just really sad, okay? And this is still true, okay? So this was actually like way worse, probably 10 years ago, right? Does anyone ever remember Quirks mode for IE, right? Like what? That's like the most messed up thing when your application, like imagine if your OS had the equivalent of Quirks mode, right? It's like, I'm going to put you in this weird mode where all the system calls work a little differently, right? Because I'm trying to use that to work around some broken websites that people wrote for older versions of IE. So IE used to have a way, like how this worked was that IE used to have a way where you could put this declaration on the page that would essentially cause it to render things differently for no reason, other than the fact that maybe it made your web page look a little bit better. So it was like, does my app work? No, try turning on Quarks mode and run it again. Maybe it'll work that time. If it does, then just leave Quarks mode on, because clearly that's what you need. So yeah, that was strange. Some of this, again, I would argue some of this is improving slowly, and he'll mention why in a few minutes. I mean, there are now things like WebKit, right? So for layout, a lot of the browsers are using basically the same rendering engine. IE still not so much, but I think Chrome, Firefox, maybe Safari, use a common library for for performing the process of taking HTML and CSS and converting it into this pixel map that you see when you go to the page, right? Has anyone ever seen like layout differences that were caused by different browsers? This is particularly, yeah, because I mean, this is hard. Give the people that wrote these browsers some credit. This is very difficult to get right. And then if you want to do any sort of weird scripting or whatever, I mean, my favorite is I still go to these websites that are broken on every other browser but Internet Explorer. And the best thing is they don't know that, right? So they just fail. You're clicking on something that looks like it should be able to be clicked on, and it doesn't work, right? And then you're like, OK, let me fire up my Windows VM and see if this works on it. Of course it works on Internet Explorer, right? So anyway, so this is very, very frustrating. And it creates a lot of headaches for people that are trying to develop these interactive web pages. Even if you just want your web page to look the same on different browsers, it's still not that easy, much less behave in the same way. That's even harder.
So here's an outline to write this talk. So first I'm going to give you some case studies to show you how exactly browsers will fail you, and then we'll unpack that. Now, that discussion is going to motivate the design and implementation of our new Atlantis browser. I'm going to give you a few slides of implementation, and then I'll talk to you about the way it works, and I'll conclude. So let me teach you a little bit about it, okay? So I go out there, I go talk to professors, and I say, look, man, these web browsers, they're terrible, they're buggy, they're ruining my life. Now, typically I tell this to the professor kind of laughs like a James Bond villain and says, James, please, calm down. When I code my web page, I use an abstraction JavaScript library, like jQuery or something like that, that's going to hide the underlying vagaries of the platform. And basically they accuse me of being foolish and hysterical and basically to seek professional help. So this is probably what many of you out there think too. So you may be vaguely aware that web browsers may be a little bit quirky and dangerous, but essentially they're kind of cuddly and cute, kind of like a nice little elderly couple that lives near a particle. And so most people think that these browsers export a largely powerful set of browser APIs. And then what an abstraction library like jQuery can do is then take those APIs and then present a nice browser interface to your web app.
All right, does this make sense? First of all, that's clearly made up, okay? Because if you've been to faculty web pages, you know that most of the faculty web pages do not use jQuery, right? Or haven't been updated since 1995, right? One of the two, right? Or both. So I totally don't believe that. I think if you talk to 10 professors and see, even in computer science, 9 of them will be like, what is jQuery, right? But what's the premise here, right? How many people have used jQuery before, right? Okay, great. So what is jQuery supposed to do? jQuery is supposed to help you with what? There's this problem that we've identified, which is different browsers work differently. And jQuery comes to the rescue in what way? Yeah.
It helps you interact with the download.
Yeah, so jQuery is, in theory, jQuery is designed to paper over some of the differences between different web browsers. So I've never looked at the jQuery source code, but I'm assuming deep inside of it, they do some browser detection somewhere when you load jQuery on the page. And then, depending on what browser you're running, the core jQuery features and functionality that you access work a little bit differently. So for example, if one browser's DOM traversal is a little bit different than the other browser's DOM traversal, jQuery will just do the right thing. And you can just write your jQuery expressions, and they will work the same way on different pages. So this is the dream, right? This is what's supposed to happen. Let's see what actually happens.
That's what you think. Now, here's the way it actually is. These browsers are murder speeds, okay? And so what they do is they present you a plain, semi-consistent set of APIs. And so what this means is that jQuery, or applications like jQuery, yeah, they can really type interface. It is in fact nicer. The problem is that this interface is only partially browser readable. As it turns out, jQuery cannot actually hide all these cross-browser compatibilities. And so I'm going to go into more detail on it. So take my hand, if you will, and join me on the garden path that I like to call why the suicide rate for web developers is 89%. let's get started. So, James Lincoln versus browser, round one. Let's take a very simple web page up here. You've got a button inside a div, inside a HTML tag. Very straightforward, right? So what the browser does, it's going to take this HTML and form what's called a DOM tree. The DOM tree is a JavaScript data structure where you just have a node for every tag in the HTML structure. So when I click the button, there's going to be this event propagation model. Now, the standard people tell me that there's an official three-phase event model: the capture phase, the target phase, and the bubble phase. So I click on that button, and during the capture phase, the browser traces the path from that topmost HTML tag all the way down to the unit generating the event, which in this case is the button. So the browser in the capture phase hands the event to the HTML tag DOM node. Says, have you defined a capture handler? The answer is yes. So that browser executes that handler. Then it takes the event, hands it down to the div node. Div node does not define a capture handler. And then the browser hands it down to the button. Now we're at the target phase. This is the thing that actually generates the event. So the button has defined an event handler. The browser executes that. And now we're in the final phase, the bubble phase. So we trace that reverse path in the capture phase. The div tag has defined a bubble handler that executes. We come up to the HTML DOM node. It has defined a bubble handler. And now we're done. So here's what possible looks like. I just want support for that official three-phase event model, right? That's all what I want. Now, Firefox says, yeah, okay. Chrome's going to say, yeah, okay. IE not going to say, yeah, okay. IE says, I will not support the capture page. Cheers. Have a happy Christmas, okay? Now,
Does this make sense? Maybe if you guys haven't done web programming, this is sort of new to you, right? So it turns out this happens when you click on a web page. All of it. Maybe you never knew this. So the idea is, wherever you click on the page, there's these two things that happen. First of all, there's this one type of event that propagates downwards from the root of the page. So the page is represented in the document object model as a tree. Every little item on that page has a path to the root. It's to some degree like a hierarchical file system, and you can name it. That's what XPath is for. So in the first phase, and I'm sorry these slides are so blurry. I should have grabbed the deck. In the capture phase, the event propagates downward from the root to the node that generated the event. So I clicked on something. There has to be some element of the page that was targeted. And this gets really complicated because I can have elements that overlap, and I can set heights for them, so whatever. But there is some element that I clicked on. Capture phase, I go down. The element itself has a chance to process the event in the target phase, and then it propagates back upwards. And the idea is that in order to implement various types of interactive behavior, various elements on this path can define handlers for these events. So give me an example of what one of those handlers might do. Like, what happens when you click on a web page? Nothing? What's that? That probably has some file system dialog that's required, right? A more typical thing. You click on a web page in a particular spot, and what happens? Nothing. It's pretty boring. It could open a new page, right? Now that might be handled directly by the browser, but what's it like a JavaScript thing that happens? Yeah. What's that? No, that's what's going on behind the scenes. Why are you doing this? Yeah. Really?
Like changing a drop-down menu or something.
Yeah, I might open a drop-down menu. Okay, that's a reasonable answer. What else? Right? I suspect you guys do this fairly often to do a variety of different things. Like what? Alerts? Come on. You guys use the internet, right? Like, you click on web pages. Really? You see those alert boxes? Those are very ugly, by the way. Like, please don't use those on your web pages, right? That's another clue that it's time to go away. Alerts are firing. No, like a menu opens, or email gets sent, or the movie starts to play, or the music starts to play, or whatever, right? Or I locate, like, by the way, Google Docs is just entirely a big blob of very, very, very complicated JavaScript. Like, the cursor moves to a new location and it lets me start typing, right? I mean, this is how you interact with web pages. Every time you do this, this is happening. And the model is designed to support a lot of different types of behavior. So for example, the document has a chance to observe every click inside of it, if it wants to. There's cases where that's useful. You can probably imagine, various types of web pages or web applications that you'd like to build, where it would be nice if not only could I do something when a particular button is clicked, but the page actually gets notifications every time you click anywhere, right? That's during the bubble phase when it comes down from the top, right? All right. Oh, this is bad. My events are not bubbling properly into this window.
This is hugely problematic. Why does this happen? Well, it happens because different browsers have different downstream implementations, right? Some of these downstreams are vibrant and full of life, they're overflowing with joy. Other of these downstreams are still more minimal, but they still possess certain tree-like characteristics. And other downstreams are so horrifying that I don't feel comfortable discussing them in polite conversation. So, James Dickinson's browsers in here, part 2. So, let's say I have a text box in the web browser, and I just want to enter my name in the text box. Sounds pretty simple, right? So I'm going to take my mouse and click on that text box, that generates what's called a focus event. Okay? I'm going to type my name into that text box, then I'm going to take my mouse and move it somewhere else. That generates a blur event, or at least it should. So here's what I want. I just want the blur event. I can hope I can have it. I actually want that. What's going to happen? I use it until I get okay. Chrome is going to say, sometimes I'll fire that event, but sometimes I won't. You just have to see one. And then Opera's going to say, you want blur? I'll give you a blur. In fact, I'll give you multiple blurs. Okay? Well done. Well done. Why is this? Once again, these dominant implementations are not completely equivalent across browsers. So, let me give you a class example.
All right, so makes sense? Again, I mean, you guys are aware of this. What is the blur event used for? You guys might have been to a website that was designed in the last 5-10 years. Uses this to do what, maybe?
To like make login screens and stuff pop up. To grab your attention.
Yeah, well, I could do that, but remember the blur event's weird, okay? Because it's fired when I've entered something into a box and then I leave it. What might the page want to do at that point? That would be awesome. That would be like helpful. Let's say you're filling out, like you're buying something online and you're entering some information into a form. What can the form use the blur event to do? Yeah. Well, that's gonna happen when I tab, and there's a way to order the fields in which the fields show up. But what might I do when I leave? Autocomplete, or I could validate the input too. You've probably been on, I mean, how many people, it's very frustrating, right? Like our expectations about web pages are changing. It used to be that you put in all of your information and then you hit submit and then the page would sit there spinning for a few minutes and then you would get an error message being like, you didn't fill out the state or something like that. And now what happens is, or you misspelled your name or the credit card number is invalid. And now what happens a lot of the time is as you're entering the information, the form is actually doing validation in the page, right? So by the time you actually get to the submit button, we're pretty confident that that's a Visa card that you entered and it's a valid card number. It has the right number of characters at least. At least we know that, right? Those can be done by the blur events. When I leave the box, that's when my input is complete and that's when the right time to do validation. All right, I don't know if we're going to get much farther than just letting James outline the problem. But
So Leon, what I want to do is I want to specify an element size of the vicinity of those elements. So this very simple example here, I want one div that's going to be slightly smaller than the other div. And specified as a percentage being happened is as you can understand by now, because the browser is a component, okay? So now we have the browser.
just skipping ahead here.
And so inside these pages, we have what's called, this master kernel is very responsible for doing things like creating a new frame, passing messages between the frames, forcing these message actions to communicate to this kernel here. And so this is very, very nice, right? What does this give you? This gives you improved security. But what we see is that these microkernel browsers use off-the-shelf components to implement things like the JavaScript interpreter and HTML. So what's the implication of that? That means that there's no change in extensibility.
All right, I'm just going to pause, James. I'll cut to the chase since I know we're almost out of time. You guys can watch this online at your own leisure and maybe actually be able to see it. So essentially, the solution that James proposes is pretty clever. He says, look, there are all. So what happens right now is the page comes down and has to deal with all of these cross-browser incompatibilities, and it's extremely hard for browsers to provide this huge interface to support all the things that a page might want to do. So what we do, let's design a new browser interface. So he refers to this as an exokernel browser. We haven't talked about kernel structure yet. We probably won't this semester. But the idea here is let's change the interface. So how do we make the browser interface a little bit more like the operating system interface that we're familiar with? What would so if you're thinking about a minimal browser interface, the most minimal browser interface possible, what are some of the things that it has to do? It is not the null set, clearly it has to do something, but what are some of the things that the minimal browser interface would have to do? What do I have to do to get Web Pages to work? Yeah, Steve. Nope, not true. Minimal. I do not have to parse HTML. What do I have to do? There are things I have to do. What's one of them? Yeah. Okay, so I do have to let the page open network connections. That's important. That I can't get around. If the page can't do that, I can't communicate with the outside world. What else do I have to let the page do? Yeah.
Show the user interface.
Render an interface. How am I going to render that interface? What's the simplest, most minimal way to render a browser interface that requires the smallest interface and lets the sort of tiny little new browser do as little as possible? Yeah.
Just text.
Oh, even simpler than that. That would be kind of a boring web page too, right? It's like links in the browser, right? What's the tiniest interface? Yeah. No, I mean, I do want pictures on my web pages, guys. Sorry, I'm sorry, I do not want to go back to the 1970s, right? I do want pictures. Pictures are good. How do I render pictures, text, other types of content? Yeah. Nope. Again, I'm not doing that. That's too hard, right?
Being able to draw
Pixels,
pixels.
yes, right? Pixel, position, color. You can use that to do anything. Okay, I can render text, I can render images, whatever. Now, what does that mean? What does it mean about the page? If the low-level interface is pixels, I probably don't want to distribute my web page in pixels. Those would be big web pages and very difficult to manipulate. So where does the HTML and CSS rendering have to happen? Somewhere else. And so the key idea here, which I'll just sort of leave with, and maybe we'll talk about this more on Monday because this is kind of a fun project, is that the page is allowed to specify its own interpreter. So the page says, I'm an HTML and CSS page. And when you download me, you also download the interpreter that converts HTML, CSS to pixels. Why does that help? Why would that solve some of the problems that we're trying to address here? I mean, at least we can agree that this thinner interface should be easier to secure. It's a lot smaller. But how does this prevent the problems that we've been talking about? Yeah, Rob. Right, so the web page is, by specifying its own rendering engine, the web page can be 100% confident that it will look identical on every browser. I don't have to hope that IE is going to render the width properly, as he talks about in the last example that we skipped, right? I have my own engine, and that engine spits out pixels, and I know it's correct. I've tested it. All I have to do is test it on one browser, and if every browser worked this way, every user would see an identical interface. Yeah, Steve.
This is just the complication from a user programming the browser to the developers who are going to have to create these engines and their perfect web page.
Well, here's the thing, though, right? Do we need to create any new rendering engines? Oh, we've got them, right? All this would mean is that if IE worked this way, your browser could say, by the way, IE, I want you to render my page using WebKit. Thank you. And I want this version of WebKit, this exact version. Thank you. And then every Chrome, Safari, IE, if all of them worked this way, you'd see the identical page. Does that make sense? Yeah, so absolutely. There are libraries involved here. We have not reduced any complexity from the process of page rendering and processing, but what we have done is change the interface that the browser has to support. And that's pretty powerful, all right? take a look at this. This is a cool project. Watch the rest of the video. There's some more fun examples. Watch some of James's other videos because, again, they are quite funny. And good luck with the rest of assignment 3. I'll see you guys on Monday. And implemented and distributed, the world has changed quite a bit. So I would say, today, millions of people create apps, right, that run in a sandboxed environment and manipulate a rich windowing interface in order to communicate with users. But those aren't native apps. What are they? These apps don't run on top of the operating system. Where do they run? You guys probably use these apps on a regular basis. How do you launch them? Where do they run? They run in the browser. How many native apps do you guys actually use on a day-to-day basis? How many people would say like under 5? Include the browser. For me, it's like browser, iTunes, which is a total piece of crap. I hate that app. I wish it ran in the browser. It could not run worse, right? It is the weirdest, most broken piece of software. Trying to think of what else. My terminal, I guess that counts. I'm at 3. Sometimes a PDF viewer, but that always makes me very sad when I have to do that. I would much rather have stuff like Google Docs. It's amazing that Google Docs' annotation features are better than PDF viewers. I find that to be shocking, but it is also true. So I'm at like maybe 4, maybe 2 different PDF viewers because one of them's always broken in some weird way that the other one isn't. Anyone like 10? Maybe an IDE? So maybe we're at 6. Anything else?
Slack.
What?
Slack.
Slack? Use an app for Slack?
Yeah.
Why? Doesn't it run in the browser? I just go to some website. Oh, okay. That's just for notifications. Okay, that doesn't really count, right? I mean, normally you go to the web page, you use Slack. It might have an app that like pops up notifications or something. But Skype, maybe. What else? I mean, this number is dropping, right? What's that? LimeWire. Okay. Yeah, great. Alert the FCC. What's that? Well, I don't know what that is. Oh, okay, gotcha. It's even dodgier. It's dodgier software than the dodgy version. So like, this is interesting, right? And I don't, this is one of those technology transformations that I don't think anybody would have predicted 20, 30 years ago. That, native apps are now native apps are alive and well in one place, which is kind of interesting. Where is that? Okay, yeah, that's true. Games, right? So games still typically native apps, but there's one platform where native apps are still ruling, yeah. The phone. I don't know why that is. It's very interesting. I'm very curious to see what will happen. My prediction is that those apps are going to go away. So I love to point out the fact that my wife uses Facebook and Gmail on her phone, but she does not have those apps installed. She goes to the web page in Chrome, and that's how she accesses Facebook on her phone. The thing that's amazing is that works. And apparently it works well enough that it doesn't drive her crazy. Same thing with Gmail. Like the Gmail mobile interface is terrible. It makes me cringe. It's really ugly. You guys can watch that on your own time. I'll send a link. That's James. James is very funny. And that talk is full of a lot of good points. So today what we're going to do is we're going to talk about a paper that James wrote. James Mickens, famous computer scientist. Definitely the Pareto optimal computer systems researcher when you talk about smart and funny. Like, there may be smarter researchers and there may be funnier people, but there is no systems researcher who is both smarter and funnier than James, right? That's a null set. I think you guys know this. People here maybe are done. How many people are done? Yeah, okay. Everyone else is just brave. let's kill some time in class. All right. So I like that. I'm taking a break, you know. Haven't slept for a while. You can do some sleeping now. That's cool. So 17% is where we were this morning. You guys have a long way to go to get to 70, 80, 95. It usually just goes upwards, hopefully. So yeah, please do the course evaluation. I'd appreciate that. Unless you're waiting to do it because you hate me right now and you think you might like me better in a few weeks, in which case it's fine to wait. Just don't wait until after the exam. All right, so we've talked about virtualization this week, and I thought this paper would be a fun thing to look at to sort of bring us full circle, because it's sort of interesting. I mean, we've been talking about operating systems and operating system concepts, and yet in the decades since operating systems were designed,
Yeah.